Now let's look at problem 9. This is another problem in conversion of units. So we need to convert 1 ton, which is equal to 2000 pounds, to ounces. So we start off with 1 ton and we need to find its equivalent in the units, which is ounces, OZ. So let's look at the equations that we know. 1 ton equals 2000 pounds and 1 pound is equal to 16 ounces. So from this equation, we can think of two fractions. 1 pound over 16 ounces and the other fraction is 16 ounces over 1 pound. Each of these fractions, think about it, 1 pound, the numerator, is equal to 16 ounces, the numerator. So if the numerator is equal to the denominator, the fraction is always equal to 1. So that's equal to 1. Now look at the other fraction, 16 ounces divided by 1 pound. This is also equal to 1 because 16 ounces, the numerator, is equal to 1 pound, which is the denominator. So when we multiply a number with 1, the number does not change. So we can take 2000 pounds and multiply it with either one of these two fractions that I've written down. Each being equal to 1 is not going to change the quantity, which is 2000 pounds. But we are going to multiply with something that works for us. We want to cancel pounds because we want to change the pounds to ounces. So we want to cancel off the pounds and make sure that ounces is in the numerator. So therefore, we choose to multiply with the fraction 16 ounces over 1 pound. So the minute we multiply 2000 pounds with 16 ounces over 1 pound, notice that the pounds cancels with the pounds. The units, ounces, OZ in the numerator survives. So that becomes our final unit. And when we multiply the numbers together, which is 2000 pounds with 16 ounces, we get 32,000 ounces. So we started off with 1 ton, and now we know that 1 ton is equal to 32,000 ounces. So we've changed the units of measurement from tons to ounces. Now in the next problem, let's read this. So we look at part A. A warehouse is 40 yards long and 25 yards wide. So it's a rectangle with length 40 yards and width 25 yards. It is piled with cartons that are 3 yards. What is the area of the warehouse floor? So first, let's answer that question. Area is length times width. So we know what the length is, 40 yards times 25 yards. So here we are not only multiplying the numbers, but we also have to consider the units. So 40 times 25 is 1000, and yards times yards is square yards, because x times x is x squared, yards times yards is square yards. So that is the unit of area. So our final answer is 1000 square yards. That is the area of the warehouse. Now the next part of the question says, what is the total volume of the uh, cartons. So this warehouse is filled with cartons 3 yards high. Okay, so the volume is equal to length times width times height. So the length is 40 yards times 25 yards times 3 yards. 40 times 25 times 3 is equal to 3000 yards times yards times yards is cubic yards. So our final answer is 3000 cubic yards. Now the next problem. A can has a circular base. So we have a circle as a base, and we're talking about a can of height 4 inches tall. The area of the base is given to us. So area of the base is the area of the circle here. So we don't need to calculate the area that is given to us. So volume in general of a solid is the area of the base times height. So we are given the area 6 inches squared. The height is 4 inches squared. 4 inches. We multiply the numbers 6 and 4 to get 24. Now we also need to consider the units. So here is how we do the calculations with the units. Square inches, so inch squared times inch. Square inches is inch times inch, and then there's another inch, so there are 3 inches all multiplied together. So that's how we get the units, which is cubic inches. So our final answer is 24 cubic inches. Now in the next problem, we need to convert cubic feet to cubic inches. Now normally in any table that gives the conversion equations, you'll see something like 1 foot equals 12 inches, but rarely a table would have a relationship between cubic feet and cubic inches, but we can figure it out using the equation 1 foot equals 12 inches. So let's see what it means when we say 1 cubic foot. So 1 cubic foot is 1 foot cubed. What that means is 1 foot times 1 foot times 1 foot. So we need to convert each of these measurements, each of the 3 measurements, into inches. Each one is in feet. We need to convert each measurement into inches. So 1 foot is 12 inches. So that's how we get the 12 inches times 12 inches times 12 inches. So 12 times 12 times 12, that's how I get the 1728. Inch times inch times inch is cubic inches. So what we have is 1 cubic foot is equal to 1728 cubic inches. Now in the next problem, an air conditioning system can circulate 320 cubic feet per minute, and the question says convert that cubic feet per minute into cubic yards per minute. So 320 cubic feet per minute, and we've discussed what per means. Per is just division. So 320 cubic feet divided by 1 minute. So we want our answer in yards cube, which is cubic yards per minute. So we don't have to worry about the unit of time, which is in minutes. We can leave that alone. The only thing we need to change is cubic feet to cubic yards. So let's look at how that works over here. We know that 1 yard is 3 feet, and that we can get from any standard table. 1 cubic yard is 1 yard times 1 yard times 1 yard, just like we did in the previous problem. Each of these measurements in yards has to be converted to feet. So 1 yard is 3 feet. 1 yard is 3 feet. 1 yard is 3 feet. So 1 yard times 1 yard times 1 yard is 3 feet times 3 feet times 3 feet. Multiplying all the numbers, 3 times 3 times 3, we get 27. Feet times feet times feet, cubic feet. So we have the conversion equation. 1 cubic yard is equal to 27 cubic feet. Now this is the equation that we're going to use to convert cubic feet to yards. Now we've done this before. We have two fractions, 1 cubic yard over 27 cubic feet, or 27 cubic feet over 1 yard. And we multiply with either one of these fractions depending on what we really want. So since we need to convert cubic feet to cubic yards, we want to make sure that cubic feet is in the denominator, so it gets cancelled with the cubic feet in the numerator. So we multiplied with 1 cubic yard over 27 cubic feet. So the cubic feet get cancelled and the cubic yards remain in the numerator, and that's exactly what we wanted. So combining the numbers that are left over, we have 320 divided by 27, and then the units that are left over, we have cubic yards in the numerator and minutes in the denominator. So our final answer is 320 over 27 is 11.85, and then our units that remain cubic yards per minute. Now we're going to do some calculations with currencies, and we just have a table that describes currencies here. So let's look at problem 13. As you leave Paris, you convert 4,500 euros to dollars. How many dollars do you receive? So first, we need to figure out the conversion rate or the conversion equation from dollars to euros. So if we look at row 3, this is the row that we are looking at. So row 3, that is for European euros. Notice this is dollars per foreign currency, and this is foreign currency per dollar. So from that information, we know that $1.256 is equal to 1 euro, because we're converting dollars to foreign currency. So $1.256 is equal to 1 euro. So now we have 4,500 euros, and we need to convert it to dollars. So in any conversion equation, we have two ratios, but we multiply it with the ratio that works for us. We need to cancel out the euros, so we want to make sure euros is in the denominator, and we want our final answer to be in dollars, so dollars is in the numerator. So the multiplication gives us our answer in dollars. We multiply the numbers 4,500 with 1.256, which gives us 5,652, and the units that remain are dollars, and that is our final answer. So the technique that we are using here, where we multiply it with a fraction, so we cancel off the units that we don't need, This technique is called dimensional analysis. Now, looking at the next problem. Cantaloupes sell for €1.80 per kilogram. Okay, and we need to find our price in US dollars per pound. So here we have to do two conversions. One is we need to change euros to dollars, and our second conversion is we need to change kilograms to pounds. So we need two conversion equations. Looking at row 3 again, we have $1.256 equals €1, and this equation will help us convert euros to dollars. Now, the other equation we have is 1 kilogram is equal to 2.205 pounds, and that's given to us, and that will help us convert kilograms to pounds. So let's see what we have. The cost is 1.80 euros divided by 1 kilogram. So 1.80 euros per, which means division by 1 kilogram. Now let's first convert the euros to dollars. So we take 1.80 euros divided by 1 kilogram and multiply it with our conversion fraction, which we get from the conversion equation. So we go $1.256 in the numerator divided by €1 in the denominator. This helps us cancel the euros. So now our answer is in dollars per kilogram at this point. Now we need to change the kilograms to pounds, so we multiply with 1 kilogram over 2.205 pounds. So we want our pounds to be in the denominator because we want our answers in per pound. The kilograms get cancelled and we get what we want. Combining all the numbers using your calculator, we get 1.03, and that the currency is in dollars per and the weight is in pounds. So that is the final answer, $1.03 per 1 pound.